Welcome to this brief analysis or an analysis rincus. Today we're tackling a massive, universally debated health topic, the metabolic effects of cold water. I mean, we literally all drink it, right? But the science behind how temperature actually impacts our bodies is where the real story lies. Rather than just relying on random anecdotes, we're going to unpack the physiological theories that have made this specific topic such a flashpoint in the wellness space. It's a simple, everyday action, but it comes with a surprisingly complex physiological debate attached to it, all based on the fascinating source text we're examining today.
Okay, let's dive into this. Cold water and weight gain. It's an incredibly compelling pairing, isn't it? The suspense around this claim really stems from some fundamental misunderstandings about how our bodies process different temperatures of water compared to our baseline internal body heat. We're all taught about thermodynamics and how our core temperature remains heavily regulated. But think about it. What actually happens when you introduce ice-cold water into a system that's designed to run at exactly 37 degrees Celsius or 98.6 Fahrenheit? That sudden drop in temperature is so often cited as a shock to the system, and parsing whether that shock impacts one of the most universally tracked metrics in human health, weight gain, is exactly what makes this source material so absolutely critical to analyze. And this brilliantly illustrates how this debate truly transcends cultural and linguistic boundaries. Whether you're looking at the English framing or the Malay counterpart, the core premise is completely identical. Across so many different cultures, this fundamental question of truth versus fiction persists regarding our daily hydration habits. For instance, in many traditional practices, there's this long-standing belief that consuming cold water dampens your internal digestive fire, potentially slowing down your metabolic rate and leading to weight retention. But conversely, modern Western metabolic studies often look at the exact same action and attempt to measure it purely through the lens of caloric expenditure. Seeing these two languages side by side perfectly captures how a localized health practice becomes this pervasive global question. Pernah ka Anda terfikir? Fact or myth? When you strip away all the complex medical jargon, it really just boils down to the singular binary choice. Let's look at what the myth actually claims. A very common theory is that cold temperatures essentially solidify fats in your digestive tract right after a meal, making them much harder to digest and therefore more likely to be stored as excess weight. On the flip side, proponents of the fact camp, those arguing that cold water actually aids weight management, point straight to thermogenesis. The body literally has to expend energy, burning calories, just to warm that cold water up to your internal body temperature. So the crucial point is figuring out which side the science actually supports, and whether that caloric burn or that digestive slowdown is statistically significant enough to really matter. Now, what's really interesting about this slide is how it brings us to the ultimate unresolved provocation from our text. We've seen how centuries-old cultural myths completely clash with modern metabolic theories regarding temperature, thermogenesis, and digestion. We know the body expends a tiny amount of energy to heat water up, and we know for sure that fats require a warm environment to efficiently break down. But when we look at the hard data and synthesize these physiological processes, does the temperature of your daily hydration actually tip the scales? The source tees up this mystery perfectly to challenge our assumptions. Based on the scientific evidence and metabolic theories we've just unpacked, what do you think? Fact or myth?